Good afternoon. Welcome to this special tutorial. Today we'll be learning Polygon. And under Polygon, we'll be able to identify a polygon. That's the first thing. The second thing is to name some special polygons. Calculate the number of diagonals formed by a polygon. Differentiate between concave and convex polygon. Find the relationship between the interior angle and its corresponding exterior angle. Calculate the number of non-intersecting triangles in a polygon. Calculate the sum of the interior angles of a polygon. Identify a regular polygon. And finally, calculate the area of a regular polygon. So that's our specific objective. So let's start with the first one. Let's identify a polygon. So a polygon is a shape formed by three or more intersecting line segments, such that at most two line segments intersect at one point, and each segment meets exactly two other segments. So from this definition, they are telling us that polygon must be formed with line segments. So it must be formed by lines, not curve. And it must be line segment, meaning a segment, from the definition, a segment is just a line that has endpoints. So like this line here, this is a line segment. So it has the endpoint. So we are going to form a polygon using line segments. That's the first key point. Secondly, it must be three or more. So we can't form a polygon with only one or two line segments. It must be three or more line segments. And also, at most, two line segments meet at a point. So at every point, only two line segments will meet there. And each of the line segments will meet exactly two other line segments. So let's form a polygon. So like this one line is not a polygon because we have only one segment. So let me duplicate it. I have two. So this is not a line segment. This is not a polygon. Though from the definition, two meet at a point. So they met at this point, but yet it's not a polygon because you have only two segments. So finally, let me add. We have three line segments, but you can't call this a polygon because they say that each line segment must intersect other two line segments. So you see that line segment 1 intersected 2, but the other two, this and this, intersected only 1. So it's not yet a polygon. Okay, finally. Okay. Exactly, this is now a polygon because we have three line segments and each of them intersects two other line segments. So this is a polygon. Okay, look at this. This is not a polygon because this is not a polygon because at this point, three line segments meet at a point. But from the definition, they told us it must be only two at every intersection. So, but we have three. So this is not a polygon. So that's it. So this is not a polygon. And maybe let me form another polygon. This is a polygon. This is a polygon, yes, because at every intersection we have only two line segments. Okay, from the definition, since they told us that it must be three or more line segments, so the smallest sided polygon is a triangle because we have three sides. So the three-sided polygon is called a triangle. Four-sided is called a quadrilateral. Five-sided is called a pentagon. Six-sided polygon is called a hexagon. 7, heptagon. 8, octagon. 9, nonagon. 10, decagon. We still have others, but for this lesson, we are going to learn only 10. But most questions will revolve under this 10. So we are done with that. So the next specific objective is to find number of diagonals. So as you can see, they said every vertex of a polygon has 2 adjacent vertices and n minus 3 non-adjacent vertices, and will form a diagonal by joining 2 non-adjacent vertices. So let me now tell you what a non-adjacent vertex is, and also what an adjacent vertex is. Okay, let me just get this line segment. Let me copy it. So let me change the color so that we can see it. Okay. So a non-adjacent vertex is the okay. Let me use vertex B. So see the vertices in this. This is a 4-sided polygon. This is a quadrilateral. 1, 2, 3, 4. So let's look at vertex B. A and C are the adjacent vertices of B. Do you get? So the one that forms a side of that polygon. So for vertex B, A and C are the adjacent vertices. So the vertex that forms a side is the adjacent, while the non-adjacent is the one that forms the diagonal. So for B, the adjacent vertices are A and C, while D is the non-adjacent vertex. So that's it. So that's what we are trying to, that's what we are saying. So from here, you notice that they said every vertex must have n minus 3. And of course, in any polygon, n is the side. So if n is the side, for us to get non-adjacent vertices, we'll subtract 3. Because we have 2 adjacent. And if you now do, n is 4 in this case. So 4 minus 3 is 1. Have you seen why we have only 1, D, as the non-adjacent vertices? For 5-sided, each of them will now have 2. Because the sides, we have 5 sides, so 5 minus 3. So each of them will have 2 non-adjacent vertices. So coming to the major thing, because we are trying to form a diagonal. So a diagonal is formed if you join 2 non-adjacent. So for this, for the first one, which is a quadrilateral, the diagonal, we have this is the diagonal, and also this is the diagonal when we join 2 non-adjacent vertices. So we have 2 diagonals, as you can see. So for this, for the second polygon, which is a pentagon, we have this, we have this. So we are done with vertex F. So for each one, you join the non-adjacent vertices. So let's move to vertex E. So vertex F, we have 2. And vertex E, we still have yes. And finally, we have for this So I think we are done. No more diagonal. So let's look. For I have this. For H, I have that. So that's it. We are done with this. Y for 6 sides. Let's start with vertex N. So that's 1. That's 2. And that's 3. So we are done with vertex N. So let's check for M. One, two, and finally 3. From what we said, n minus 3 non-adjacent. So in this case, we have 6 sides. So each of them will have 3 non-adjacent vertices. Y for, we are done with M. So let's move to L. We've joined 1 because we can't repeat. That's 1. This is the second one. And finally, that's the third one. So for K, we have 1, 2, so we have only 1 left. So that's it. We have any other J, we have 1, 2, 3. 1, 2, 3. So let's now count. You notice we have something that we'll get a formula from this. So for the first, let me use for this quadrilateral, what do you notice? We have 2 diagonals, so we have 4 sides. 4 sides. We have 2 diagonals. Why for this? We have 5 sides. And how many diagonals? We have 1, 2, 3, 4, 5. Yes. So we have 5 diagonals. So for the 6-sided polygon, let's count. 1, 2, 3. Okay, let me be count so that we won't repeat. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. No repetition. 9. Okay, we have 9. So we have 6 sides and we have 9 diagonals. So we can't just continue counting like this. We want to get a formula for that. So what do you notice? Since we can use our common sense here, since each vertex, since we are forming a diagonal with non-adjacent vertices, and each of the vertices will have n minus 3 vertices, non-adjacent vertices. So the total diagonal, that's the total, since 1 has n minus 3 non-adjacent vertices. If we now have n vertices, so the total will be n times n minus 3. Do you get the logic? 1 will have n minus 3. So 2 will still have its own n minus 3. So for n vertices, it will have n minus, total of n times n minus 3 non-adjacents, forming the diagonal. But there is a problem here. Some of the vertices are repeated. Some of the diagonals are repeated. So to avoid repetition, we now divide by 2. So I'm now saying generally, the number of diagonals of any polygon is always equal to n times n minus 3 over 2. Yes. Over 2 to avoid repetition. So let's test whether we are correct. For 4 sides, we have 4. 4 minus 3 is 1. So 4 times 1, 4 over 2. So we have 2 diagonals. So for this, I have 5 times 5 minus 3, which is 2 over 2. So we have 5 diagonals. And finally for this, we have n is 6. So 6 times 6 minus 3 over 2. 6 minus 3 is 3. 6 over 2 is 3. So 3 times 3 is 9. They said, find the number of diagonals of the following polygon. So for the first one, so for an octagon is an 8-sided polygon. So n is 8. Therefore, the number of diagonals is now 8 minus 3 over 2. So I have 8 over 2 is 4. 4 times 5. So this will have 20 diagonals. So we are done with that. The second, nonagon. So n is 9. Remember, nonagon is a 9-sided polygon. So which implies that we have 9 times 9 minus 3 over 2, which is 9 times 9 minus 3 is 6 over 2, which is 9 times 6 over 2 is 3. So we have 27 diagonals. And finally, decagon. A decagon is a 10-sided polygon. So we have 10 times 10 minus 3 over 2. So we have 5 times 7. So we have that 5 diagonals. So we've learned how to solve to get the number of diagonals given the polygon. So we are done with that. Let's